Welcome to the deep dive. We take the material you've shared and really boil it down to the key insights. It's your shortcut to getting a solid handle on a complex topic.
And today, yeah, it's definitely complex and fascinating too.
Yeah.
The Cardano blockchain. We're digging into this document, the future of Cardano.pdf, to pull out what you really need to know about, well, where it is now and where it might be going.
Exactly. This thing is pretty packed. It covers Cardano's basic design, the tech underneath,
Hmm.
the actual apps people are building, and, the outlook for the future.
Right?
So our mission really is to make that all clear, digestible, highlight the important stuff, the potential roadblocks,
Your trade-offs.
the trade-offs, exactly. What Cardano offers today and down the line. Okay, let's get into it.
Let's do it. So maybe start with the core idea, the value proposition. What makes Cardano different? The document points out some strengths right away.
Okay.
One thing is how predictable the fees and transaction sizes are.
Right. That's different from, say, Ethereum's gas fees, which can sometimes go, well, all over the place.
Totally. So with Cardano, you get a much more stable cost. That's got to be good for, businesses trying to budget or build things.
Makes sense.
And that predictability, it partly comes from their UTXO model.
Okay, UTXO.
Yeah, and specifically the extended version, EUTXO. And that brings in things like parallelism and formal verification.
Formal verification. That sounds intense, like proving the code mathematically.
Pretty much, it's about proving it works before you run it, which can massively cut down the risk of, like, critical bugs. It's a level of rigor you don't always see.
And what about native assets? I saw that mentioned.
Oh, yeah, that's a big one. The idea is you can create and send tokens without needing a separate smart contract for that specific function.
So it's built into the base layer. Less code to trust.
Exactly. Simpler, potentially safer for just moving assets around. Plus, you have to mention the academic foundation.
The peer review approach.
Right. They emphasize peer-reviewed research before implementing stuff. That adds a layer of trust, builds confidence in the core protocol.
Okay. And minimal chain bloat. What's that about compared to, say, Ethereum?
Well, the idea is that the computers running the network, the full nodes, don't get bogged down with quite as much historical baggage or complex state calculations as you might see elsewhere. It helps keep running a node more accessible long-term.
Gotcha. And the staking seems pretty user-friendly, too.
Yeah, the delegation model. You can stake your ADA to help secure the network, earn rewards, but you don't give up control of your coins. It's non-custodial and liquid.
Okay, so lots of interesting design choices on the plus side. But the document doesn't shy away from the challenges, right? What are the cons?
Definitely. Transaction size limits, for one. There's a maximum size for a transaction.
A big.
Around 16 kilobytes, I think the doc mentioned. And that limit can impact things, even their scaling solution, Hydra. Developers sometimes have to find workarounds.
Okay, so it creates complexity. And the EUTXO model itself, you said it allows parallelism, but it's harder for developers.
Generally, yeah. Especially if they're used to the account model, like on Ethereum. Certain things, maybe like a complex betting platform or some kinds of escrow, they become more tricky to design and implement efficiently on UTXO.
And learning the smart contract languages, Plutus, and the newer one, Aiken.
Plutus, based on Haskell, has a notoriously steep learning curve. Aiken is meant to be a big improvement. Simpler syntax, faster, better tools.
But
the tooling around Aiken is still pretty new. It's getting there, but it's not as mature as, say, the Solidity ecosystem for Ethereum.
right. And the whole peer review thing, while good for security, it means upgrades can be slower.
That's the trade-off, exactly. It's a cautious approach, which means sometimes waiting longer for new features compared to chains that might move faster and maybe break things more often.
And finally, this concept of low DApp composability. What does that mean in practice?
It means it's harder for different applications on Cardano to directly call each other and interact within a single transaction. Like how on Ethereum, one contract can easily call another, like swapping tokens and then lending them out all in one go.
That's harder on Cardano.
It often requires more off-chain coordination or different architectural patterns. It's a fundamental difference, which actually leads us nicely into the specific tech they're building.
Yeah, let's dig into those. Hydra first, the layer 2 scaling solution. What's the goal there?
The goal is faster, cheaper transactions off the main chain using something called isomorphic state channels.
State channels, like opening a private tab between a few people for transactions.
That's a decent analogy, yeah. You open a channel, do a bunch of transactions just between the participants in that channel very quickly and cheaply, and then settle the final result back on the main chain.
Okay. But the document seemed pretty realistic about its current state.
Very realistic. It works, they can demo it, but it has real constraints. It's best suited for things like micropayments, maybe recurring transfers between the same parties, or games with a fixed small number of players.
So not for a massive decentralized exchange or a big public auction.
Probably not in its current form. The private game lobby analogy in the doc is pretty spot on. It's useful for specific, contained use cases.
What are the technical hurdles holding it back from broader use?
Things like the maximum number of outputs a Hydra head transaction can have, which limits complexity. Also, the fact that participants need to commit funds up front, everyone needs to be online, and they all need to trust the same underlying script logic.
Right, so it's not just an open, public scaling free-for-all, it's more structured.
Exactly. It's a specific tool, not a universal scaling silver bullet, at least not yet.
Okay. What about Ouroboros, Leios, and Mithril? These sound like core protocol improvements.
They are. Leios is aimed at increasing the base layer's transaction throughput by sort of separating how transactions are processed from when they become final.
Boosting speed, basically.
Potentially, significantly, yeah. And Mithril is about making it faster and easier for new nodes or light clients like mobile wallets to securely sync up with the current state of the blockchain without downloading the whole history.
So faster syncing, easier access for lightweight apps. Sounds good.
The promise is definitely there. Higher TPS, easier trust for light clients and services.
But the caveats.
Well, Leios is still largely conceptual. It's not live. And Mithril, while functional, hasn't seen wide adoption yet by wallets and apps in the ecosystem. So the tech exists or is planned, but the ecosystem integration is still catching up.
A familiar story, maybe. Great ideas. Implementation takes time.
Something like that. Which brings us to the smart contracts themselves. Plutus and Aiken. We touched on Plutus being tough.
Right. And Aiken being the hopeful successor.
Yeah, Aiken's designed to be way more developer-friendly, faster compiles, easier syntax, better ergonomics, as the doc puts it.
What are the strong points of Cardano's smart contracts overall?
Well, things like native multi-sig support are built in. Script addresses offer cool possibilities. You can include data directly in transactions, which is useful. And crucially, the execution is deterministic.
Meaning it always produces the same result for the same input. No surprises.
Exactly. Which is great for predictability, auditing, knowing what will happen.
But the challenges remain, especially for dynamic apps.
Yes. That core ETXO model makes managing state that changes frequently on-chain. Well, awkward sometimes. It often requires careful coordination between on-chain logic and off-chain systems. Building something highly dynamic, like some complex DeFi protocols, requires a different mindset than on EVM chains.
Okay. And lastly, on the tech side, interoperability. Connecting Cardano to other chains. Midnight, sidechains, bridges. What's the status?
Midnight is their privacy-focused sidechain project using zero-knowledge proofs. It sounds very advanced.
Yeah.
But sidechains in general haven't really gained much traction yet.
And bridges. Like Milkomeda or Wanchain.
The document notes they exist, but haven't seen huge usage. It points to a broader challenge. Really, most blockchain ecosystems are still quite siloed.
And wrapped assets always carry some counterparty risk, right?
You do. You're trusting the entity that holds the original asset on the other chain. True. Trustless cross-chain communication is still a really hard problem for everyone, Cardano included.
So pulling back to the bigger picture, the ecosystem and developer experience, progress, but still gaps.
That seems to be the takeaway. The tooling is definitely improving Aiken, Lucid for building transactions, Plutip for testing the TX pipe stack. There's more documentation, more tutorials, better wallet support than a couple of years ago.
That's positive.
It is.
Yeah.
But the core dev experience is still often seen as less smooth than EVM, particularly because of that composability issue we talked about.
Right, not being able to easily chain contract calls together.
Yeah, things like building a direct Uniswap clone where you swap instantly between any two listed tokens in one transaction is just architecturally different and often harder on Cardano. And the doc mentions waits for features like better NFT metadata handling via CIP68. It shows that married pace again.
So, given all that, the strengths, the weaknesses, the tech, what is actually working well on Cardano today? What are the real-world use cases?
The document highlights a few. Betting or prediction markets, especially simpler ones, seem viable.
Because the logic is straightforward.
Yeah, A/B outcomes, predictable logic fits well. Even hybrid models work. But complex, constantly changing odds might be tougher.
Okay, what else?
Token launches with vesting schedules, using time locks or reference scripts to control how tokens are released over time. That leverages the native asset feature well.
Makes sense. Simple but useful.
DAOs, decentralized autonomous organizations, seem to work well when the voting happens off-chain, but the results are enforced on-chain using Cardano security.
So using the chain for enforcement, not necessarily the whole voting process itself.
Right. Also, minting NFTs, where you want really strict, unchangeable rules about how they're managed. Cardano's policy controls are good for that.
Secure asset control.
Exactly. And just the basic infrastructure for staking, running a stake pool, delegating ADA that's noted as being quite easy and robust.
So these use cases play to Cardano's strengths: security, predictability, native assets.
Pretty much. And conversely, the document suggests areas like complex DeFi, auctions with lots of participants, or sophisticated on-chain games are still, let's say, clunky or difficult due to the EUTXO model and current parameter limits.
Which brings us to those parameters: the max transaction size, block size, script limits. These aren't arbitrary, are they?
Not at all. They're fundamental constraints designed to balance performance, security, and decentralization. The max transaction size, around 16 kiloB, impacts validation time.
How long it takes nodes to check a transaction is valid.
Right. And the max block size, around 88 kiloB, affects how quickly blocks can spread through the network.
And the limits on CPU and memory for Pluto scripts, that sounds like a direct cap on complexity.
It absolutely is. It limits how much computation you can cram into one smart contract interaction, which is a bottleneck for really demanding DeFi applications.
So developers have to build around these limits.
Yes, the document stresses this. You need to think about batching operations, using things like reference scripts to reuse code efficiently, basically designing systems knowing these constraints exist.
Okay, so considering everything we've discussed, let's look forward. What's the realistic outlook based on the document? Near term, maybe the next year or two?
Near term seems focused on improving that developer experience, Aiken maturing, Lucid getting more use. We should see Mithril enabling more light client usage.
Easier access.
Yeah. And maybe some stable niche uses for Hydra emerging for micropayments. Plus ongoing incremental steps in governance with CIP 1694, the Voltaire-era stuff.
So consolidation and improvement rather than huge leaps. What about midterm, say, 3 to 5 years?
That's where the bigger tech upgrades might land. Leios and Chronos for throughput, potentially. Maybe shared state channels evolving from Hydra. We could see higher script limits, bigger blocks if deemed safe, and maybe more mature cross-chain standards if bridges improve.
Still a lot of ifs and potentials, though.
Definitely. It depends on research development and adoption. And the far term, 5+ years.
Big grand vision.
Yeah, the document paints this picture of Cardano as a potential financial operating system, a foundational layer. But that really hinges on the treasury, the governance, the funding mechanisms, all becoming sustainable and truly decentralized long-term. It's ambitious.
Okay, before we wrap up, that summary table in the document seemed useful. Can we quickly recap the main strengths and weaknesses pulled together?
Sure. Strengths. The secure, decentralized, low-energy core tech, but weakness. Slow iteration, conservative roadmap.
Strength. Native assets, formal methods, Aiken, improving smart contracts. Weakness. Still limited composability, clunky state changes for some apps.
Strength. Hydra offers niche layer 2 scalability. Weakness. Not suited for open, high-volume DeFi.
Strength. Improving dev tools and experience. Weakness. Still seen as less friendly or mature than EVM overall, fragmented in places.
Strength. Community-centric governance ideals. Weakness. Slow adoption, impact still unfolding.
Strength. Interoperability solutions are being built, midnight, etc. Weakness. Not yet trustless, low traction on current bridges.
Strength. Real dApps exist in specific areas like NFTs, simple betting. Weakness. Complex DeFi, auctions, games, still often difficult.
Okay, that's a good distillation. So as we finish this deep dive, what's the key takeaway for you?
For me, it's really understanding that Cardano represents a specific set of trade-offs. They prioritize security, formal methods, academic rigor.
Right.
And that leads down a different path than chains, perhaps prioritizing raw speed or EVM compatibility above all else initially. It's a deliberate, cautious approach.
Yeah, that's the aha moment for me too. It's not just about features, it's about the underlying philosophy. That focus on security and predictability shapes everything else, creating different challenges, but also different opportunities compared to, say, the EVM world. It's not better or worse, just different priorities.
Exactly. Different priorities, different outcomes, different kinds of applications that might thrive.
So here's something for you, the listener, to think about. Given these specific trade-offs in Cardano's long-term vision, What kinds of applications, what kind of financial infrastructure do you think is best suited to really flourish on this platform in the coming years? And maybe more broadly, what does this very deliberate research-first approach signal for the entire blockchain space? Lots to ponder there. Thanks for joining us for this deep dive.